Alright, so today's topic is going to be section 5.3. This is part B, I guess. We're going to talk about b to the negative nth power. Because already we've talked about b to the 0th power. We've talked about, again, our definition of b to the nth power is b times b times b times b itself, the base, multiplied by itself n times. And we talked about the 0th power right here. We've talked about that. B to the 0th, again, here's a take-home message. B to the 0th power is just defined as 1. So let's talk about what happens with b to the negative exponents as well. Let's go past the pages we've seen already, and we're going to talk about the situations like this. We've seen this before. This is going to be x squared. This is going to be x to the first because it's 4 minus 2 is 2. 4 minus 3 is 1. We're talking about just subtracting the exponents here from previous sections. 4 minus 4 gives us x to the 0th power. Our x is our base here that we're talking about, so we'll just rewrite this. X to the 0th power. Now what happens about this one here? Does the rule still apply that we've used here, where 4 minus 2 gives us 2, 4 minus 3 gives us 1, 4 minus 4 gives us 0, or 4 minus 5 gives us, what does that give us? X to the 4 minus 5 is the same thing as x to the minus 1. But what is that? Really, if we talk about this, x to the 4 over x to the 5, if we go the long way and we say, well, my numerator is x times x times x times x. My denominator, because that's x to the 4th power, my denominator then is x times x times x times x times another x, because the numerator is x to the 4th, there's 4 x's there, denominator is x to the 5th, and there's 5 x's there. So what happens there? X divided by x is 1. All these x's cancel out because they're just 1. What's left in the numerator is 1, and what happens is we've got 1 over x is our answer, and therefore x to the negative first. Following our rules, 4 minus 5 gives us negative 1. Following our longhand way to get around to what this represents is 1 over x, so x to the negative first is x1 over x, or 1 over x to the first power. So let's take a look at kind of making a definition of this, and this is again probably a take-home message here. If you want to take this home, put it on your study guide. N is an integer, again, any integer. B is a non-zero number. That's kind of a small thing about the rule, no pun intended, but that's something to remember. B cannot be 0. B to the negative n then is 1 over b to the nth power. In other words, you take the reciprocal of this base. Reciprocal means you turn it over on its head. You put it, you take that base and you put it under 1. So the reciprocal of b is 1 over b. The negative n changes to positive n, and there is our definition. 1 over b to the nth then is also 1 over b to the nth power. So we're going to flip back. We'll be able to flip back and forth between these as well later on, but just keep in mind that b to the negative nth power is defined as 1 over b to the nth power, or 1 over b to the nth power. So let's take some examples, take a look at some of these, and see what we can do. Again, I'll probably go through a couple of examples. You can pause this at any time and try to get a feel for what you know and how you feel, how comfortable you feel about this. Again, here's our rule. C, let's use B. B to the negative nth power. Here, let's make it clear. We'll go b to the negative nth power equals 1 over b to the nth power. And that's essentially what we're going to do. There's our rule there. We're going to keep that in mind. So what is c to the negative third power? Well, we're going to take this and we're going to define it as 1 over c to the third power. The base is reciprocated, or you find the reciprocal of the base. The negative 3 becomes positive, and there is our definition. And we can then simply say that that's 1 over c cubed. And a shortcut might be to say, well, you know what? I'm going to take that minus 3. I'm going to make a positive 3 if the base goes from the numerator to the denominator. So if it flips sides of that divided by sign, then the negative 3 as an exponent becomes positive 3. So let's try this one. Again, pause it at your convenience, go through some of these and see what you can understand. 5 to the negative first power is this is equal to 1 over 5 to the first power, or simply 1 over 5, and you can put that first power here if you want, but we don't have to. So now 5 to the negative first power is 1 over 5, and there's our next example. Keep in mind too what our base is, what our exponent is. Here's our base, here's our exponent. So what are we supposed to do? If we've got a base here of negative 3, just by definition, I say 1 over negative 3. I reciprocate my base, or I find the reciprocal of my base, and I change the negative 4 to a positive 4. And now that would be a decent first step, I guess, to make it real pretty, to make it mathematically more pretty. You'd say it's 1 over negative 3. Again, our base to the fourth power, and then you can evaluate that. 1 over 3 times 3, or negative 3 times negative 3 times negative 3 times negative 3 gives you a positive 81, and that would be our answer. How about this one? Not written real pretty, but we can rewrite it as 1 over 6 to the negative 2 power, because that's all I'm doing is writing this 1/6 as 1 over 6. What we do is we reciprocate the base. 1 over 1/6, or the reciprocal of this is just simply the flipping of it, or the refliprocal, some people would call it. So the reciprocal of 1/6 is 6 over 1. The exponent then becomes positive after you take the reciprocal of the base, and now you've got 6 over 1 squared, or 6 squared if you need to, and then 6 squared is 36, and there's our answer. Alright, negative 3 over 5 to the negative third power. Well, let's take negative 3 over 5, kind of rewrite it to make it a little clearer. Negative 3/5 to the negative third power is, just by definition, is negative 5/3. You take the reciprocal of the base. Here's our base, and again our base is this. That's our base. We take the reciprocal of the base. If the base is negative, we have to keep that negative inside as the reciprocal, and then after that we can say that the exponent becomes positive. After we've taken the reciprocal, then the exponent becomes positive. And now we can simply rewrite this as negative 5 to the third power over 3 to the third power. And that's equal to negative 5 over negative 5 to the third power is negative 125, or negative 5 times negative 5 times negative 5 is negative 125. 3 cubed is 27, and there's our answer, negative 125 over 27. Last one we'll do, 1 over, we'll rewrite this just to make it a little clearer, 1 over y to the negative fifth power. And we can put the parentheses here as well. Alright, if we've got y to the negative fifth power, this one might be a little bit more complicated if we take the definitions, but let's walk through the definitions, and we'll say 1 over, well, here's where we can maybe take a shortcut, and we can say that 1 over y to the negative fifth power is going to be this will be y to the fifth power over 1. And we can say that, well, if we've taken c up here, if we've taken c to the negative third power, and it becomes 1 over c to the third power, the power becomes positive when it flips over to the other side. So this is c to the negative third power over 1. When that c, the base, flips to the other side, then the other side of the divided by sign, then that power becomes positive. Same thing here, the base flipped over to the other side, the power became positive. This base flipped over to the other side, and the power became positive. So we're going to rewrite this 1 over y to the negative fifth as 1 over y to the negative fifth, and we're going to say, let's make this, let's take the shortcut here and say that we can make this power positive if we flip the base to the other side. So y comes to the other side of the divided by sign, the negative 5 becomes positive 5, and there's our answer. We can say that's y to the fifth power, and we've kind of taken a shortcut there. So that's going to be enough for today. Let's take some questions into class, and we'll talk about them then.